we're playing a little bit of catch up, not too much, but so I'm going to go through the ringer. I would normally give you a little bit more time, but what does the word extrema mean? If you can't see where you're sitting, you can think back to the closer. So what does the word extrema mean? Good, most, maximum or minimum. So extrema are maximum and minimum values. What is the difference between local maxima and global maxima? Okay, local is in a small little area. So if I took that to a real world application, there is a richest guy in Greenwood, right? I don't know who he is, but there is one, right? So he's locally a maximum. But is he a global maximum? No. Somebody, I think it's some guy in Mexico right now. Tech company, I think. So that he still is a local maximum, but he's not a global maximum. So that's what the difference between local maximum and global maximum. On a graph, local maximum and minima are all the peaks and valleys. The global maximum is only the highest peak or the highest or the lowest valley. So on this graph, what are the global maxima and what's the global minimum? So global maximum on that graph.
Global what?
Maximum. 4, I agree. And I like that you said 4. You didn't tell me it was 2. Why did you give me the Y value?
Where it reaches.
Good. The highest it reaches is 4. If you wanted to say something about the 2, you would be at x equals 2. That's when you hit the global maximum. But the actual global maximum is 4. That value up there. And what about the global minimum? 0. When is f prime positive, negative, or 0? What would you be looking at to see if f prime was positively sloped? So when is it positive?
0 to 2.
0 to 2. When is it negative?
2.
When, yeah, 5, you're right. And when is it 0?
2.
At the point, x equals 2, right? Only at the point, x equals 2. Because we go up, we stall for a second, get that horizontal tangent, and then we go down. So the slope is 0 at x equals 2. When is the graph increasing and when is it decreasing? Didn't you just answer that question? So it definitely seems like increasing and decreasing is very much tied to the first derivative. So that's one of the things we'll be looking at today. So before I go to the next slide, I wanted you to look at this picture. And it's a picture of absolute minimums and local minimums and absolute maximums and local maximums. Any absolute minimum is also a local minimum, right? It's both. By the way, there are 2 words, synonyms, absolute and global are the same, and relative and local are the same. So relative minimum is a local minimum, absolute is global. What I do want you to notice is look at all of the relative maxes and mins. What does it seem that the derivative is at those values? Either 0 or undefined. Agreed? 0 or undefined. So that's going to help us find maxes and mins by noting that those happen at 0 and undefined places. Not only that, but look at local maximums specifically. changes to negative? Everyone see that? Wouldn't that happen at a maximum? So those are the things we're going to be looking at today. So the first thing we need to define is a word called critical point. A critical point is a place on the graph that is a potential maximum or minimum. It has potential to be a maximum or minimum. Critical points happen when the first derivative is 0 or undefined. Extrema can only happen at critical points or endpoints. Critical points on the graph or the endpoints on the graph. So if you look at the graph below, very similar graph to the one I showed you earlier, you can see that every time the derivative is 0, we have a possible extrema. However, is this a maximum? Is it a minimum? Now, we thought it might be, but it kind of fakes us out. Those of you who are physics people, there are two things that can happen, like if I'm on a position graph. If I'm walking, I can stop and turn around, and that would give me a maximum, the farthest right I went. Or I could stop, bend over, tie my shoe, get up, and keep going. And there's no maximum there, but there was still a stall. And so that's kind of how, so we have critical points that give us maximums and minimums, and then critical points. So here's a summary. This is what you will want to write down. Critical points are when the first derivative is 0 or does not exist. They can be maximums, they can be minimums, or they can be neither one. This says fakes. I don't really like that word, but the book I got this from used it. But they can be maximums, they can be minimums, or they can be neither one.
So fakes.
Right. Like if you thought it might be a maximum or minimum, but it wasn't, so it faked you out. The only reason I don't like it is because it's not very mathematical. It's good though, because it kind of helps you remember it. Local maximums happen when the first derivative is 0 or does not exist, and the derivative changes from positive to negative. Would that make sense? If the derivative, and watch my hand, I know it's silly, but the derivative changes from positive, so we're increasing, to negative, decreasing, what's going to happen in between that? A maximum, so it makes sense. Local minimum is going to happen at a critical point when the derivative changes from negative to positive. Absolute maximums, local maximums are candidates or potential absolute maximums, but the endpoints could be the absolute maximum. So we will look at endpoints as well when we look at absolute maximums and absolute minimums. So those could happen at a critical point, local minimum, local maximum, or at an endpoint. Today we're going to focus mainly on local extrema. I might get to one absolute, and then tomorrow we will focus on absolute extrema. So first we're going to look at a graph, and then we'll do a speed test. Where is f prime equal to 0 on this graph? And we will have to estimate because all that is around -3, 1, and 2. Approximately. Could be off. Where did you look to find that? The maxes and mins, those peaks and valleys that aren't sharp corners. On what interval is f of x increasing? Good. Where is f prime positive? That is almost a silly question. That's where I've asked increasing or decreasing. So what you learn from that is a function is increasing when f prime is positive and decreasing when f prime is negative. So we would be decreasing from -3 to 1 and from 2 to infinity. Very much correlated to the first derivative. You can find when a function is increasing when the first derivative is positive. You can find when it's decreasing when the first derivative. You don't have to write this entire thing down, but this is called the first derivative test. The first derivative test is how you test to see if the critical point is a maximum or minimum. You already have it written down on the summary. I just want you to know that formally it's called the first derivative test. So the first derivative test says, let's see be a critical number. So we got a critical point, which means we've got a derivative that's 0 or undefined. The first derivative test states that if f is differentiable on the interval except possibly at c, and the reason we say maybe not at c because we know it could be an undefined critical point, then f of c can be classified as follows. If f prime changes from negative to positive, then I have a minimum. If f prime changes from positive to negative, then I have a maximum. If f prime doesn't change signs, if it's positive, then positive again, or negative, then negative again, there's neither a min nor a max. So the first derivative test tests for maximums and minimums. One of the common misconceptions is students will say this is increasing by the first derivative test. The first derivative test tests for maxes and mins, not increasing, decreasing. Increasing, decreasing, it's just whether the first derivative is positive or negative. Okay. This is where it gets useful. By the way, as you're writing a little summary of what we're doing over this chapter and the next chapter. This chapter, we're going to be looking at what the derivative can tell us about a graph or a curve. So very much the mathy side of derivatives this chapter. Chapter 4 will be more of the physicsy side of derivatives. Anyone in physics right now? Velocity, position, acceleration. We will hit all of that in Unit 4. Those of you who like to see clear something would be used in the real world. Unit 4 is where we'll really hit all the cool things about derivatives. This one is cool for us math people. This unit is cool for us math people because it lets us know some things we can do using derivatives that we couldn't do in Algebra 2. So this unit will look at what derivatives can tell us mathematically. Unit 4 will look at what derivatives can tell us real world applications. So that means next 2 units will still be in derivatives. It won't be until January when we hit the last calculus topic that comes. So this says find all extrema of x cubed minus 3x plus 2. I can only find relative extrema because I don't have any endpoints. So for right now, we're only going to look at relative extrema. We'll talk about absolute extrema maybe a little bit today, probably mostly one. So where could the relative extrema happen at? When the derivative is 0 or does not exist. So I'm going to find the derivative. Pretty easy derivative to find. What is the derivative? Okay, so I just want to point this out in case you missed the amazingness of this situation. This is a cubic function, and I'm about to work with this function without a calculator. In pre-cal, did you ever work with cubics without a calculator? Unless it was just x. You couldn't do anything with them. You couldn't factor them. They were pretty much calculator problems. So just point that out. I'm going to find when this is undefined or 0. Well, is it ever undefined? And it doesn't have a denominator, so it's not undefined. So it could equal 0. Can I solve that equation? I could either factor or add the 3 over, whichever way you want to do it. X is positive or negative 1. So those are what are called my critical values. Now, if I actually wanted to find the critical points, I would have to find the y value. Okay, so those are just the x values of the critical points. So that means I have a possible max and possible min at x equals negative 1 and x equals 1. How am I going to know if it truly is a max or not?
Let's see if it goes from.
Good. I'm going to see if it goes from positive to negative. Those of you who had me for alpha 2, or if you had a slope sheet, did the same thing. You remember me when we learned solving polynomial inequalities? I said, we're going to do it this way because it will help you in calculus. You remember the sign chart thing? So here's why I did it that way. So I'm going to do a sign chart here. I'm going to pick a number less than negative 1. Did everyone come from either me or Miss Lowe in this class? Oh yeah, dude. So you might have never seen this sign chart, so this is going to be new. But it'll be okay. I have 2 in my third hour. So to the left of negative 1, I'm going to pick a point to the left of negative 1, which is negative 2. And I'm going to plug that into the derivative. So I'm going to even label it like that so you'll know I'm plugging that into the derivative.
Why is it in the derivative?
Because I want to see if the derivative is positive or negative. So I'm going to do a sign chart for the derivative. So at negative 2, if I plug in negative 2, I would get a positive number. Agree? In between negative 1 and 1, I get a negative 3, right? If I plug it 0, I get negative 3. And 5. This next step is completely optional. You don't have to draw this or not, but some of you will like it. If this is f prime, that means f is increasing, then decreasing, then increasing. Do we agree? So what is happening at negative 1? There's a maximum. What's happening at positive 1? There's a minimum. To actually go find the extreme value, what do I need?
The y.
The y value. So I know there's a maximum at negative 1. Where would I plug in negative 1 to get the y value? The original. So I'm going to go back up to the original and plug in negative 1. And I get a max of negative 1 plus 3, which is 2 plus 4. Plus 3 plus 2 is 4. At x equals negative 1.
just like do max equals and the
You can put the reason I use this notation is it kind of saves you a little on some AP problems, because sometimes they'll ask you to put a maximum value, and I did, and sometimes they'll ask you where it happened at, and I did. And so it kind of covers all your bases in one. But yes, if it just asks for the extreme, I'd be disappointed. Min of plug in 1 minus 3, which is negative 2 equals 0. Now, this is all the question asks me to find. I'm done, but I just want to show you how much I know about this cubic, which is pretty amazing. I know at 1, 0, I have a minimum. At negative 1, 4, I have a maximum. I have a pretty good idea of what this cubic looks like. And I don't have a calculator, so that's pretty cool stuff. Any questions on that one? Find all extrema of this next one, and determine on which intervals f of x is increasing and decreasing. Pretty much on the last problem, did I do all that? So nothing really new on this problem, we're just trying to hit it. I do want to mention as you're writing this down and trying to work it, see if you can do it. On AP justification, which we will do one so you see what it looks like, but if the AP exam says justify, that they will not grade a sign chart for justification. So if you have to justify, you have to say f prime changes from positive to negative at x equals negative 1. Or f prime changes from negative to positive at x equals 1. So you have to actually put what's on the sign chart in words. Almost everything else AP will grade any kind of work, but on justification with maxes and mins, they will not grade a sign chart. I think they quit in about 2005. They used to grade sign charts, but they won't anymore. So, just random.
I want to get updates on like what they change every year.
Every 5 years, I have to go for training, or anytime there's a redesign of the AP paper, I have to go for
So y'all went to this year, to California.
Yes, I had to go this summer to BC. BC training, BC calculus, because it's our first year to offer BC calculus. So I've been training, so that was what I was supposed to start. I'm up to date on my AP. But in 5 years, well, 4 for AP, I'll have to go back. But they're good because you get to, usually the people who do it are AP readers, so you get a little insight into how they grade and stuff. I miss my son. It was the first time I was gone for a full week. He said for about 3 weeks, every time he saw me after that, "You're back, Mom." Okay, so what are we going to do first? Find the derivative. Then what? Set equal to 0, and to do that I will need a factor. Luckily a 3 factors out, so that's nice. You're okay with all of that? You can. It's long, it's a little tougher, so there's a little bit more room for error. They're my possible maxes and possible mins. To find out what they are, I'm going to do a sign chart for f prime. I'm going to plug a number less than -1 into the derivative. Remember, this step you're plugging into the derivative. That's why I'm making sure you see that light later. So I'm going to plug -2 into the derivative. I get a negative times a negative, which is a positive. I mean, sign chart, okay. And did you ever do this? You have. 0 negative times positive is a negative, and then positive is a positive. So we are increasing, decreasing, and then increasing.
Wait, you just do it from that equation right there? Is that all you have to do? Is like that?
From the derivative, any format of the derivative. I like using the factored form because it's just a little easier to plug in. But you can use any format. So where is our relative maximum? At -1, and where's our relative minimum?
3.
And how will we find the y values of those things?
Plugging them into the original.
Plug them into the original. Let's go read the question. Okay, and determine. So find all of the extrema. This time, if y'all are okay, I'm going to just label it as a point. But that other notation, like I said, is good for covering all your bases. Sometimes they'll ask for the maximum value, which is a y value. Sometimes they will ask for where the maximum happens after that's the next value. Plug -1 into the original. -1. 6, is that what you said? Yeah.
-4. What's negative?
Okay, so -1 minus 3, -4. And then we're plus 9, so 5. Plug is 3. 27 minus 27.
Yes.
So that's 0. Minus 27.
Plus 1.
Plus 1. So -6.
So you put in x.
To get the y, to get the point of where that maximum happens, the y value. And what are the intervals of increasing? From the sign chart, that's a really easy question. It's a really easy answer, isn't it? Decreasing. The AP exam, they will never count off for brackets versus parentheses on increasing and decreasing. I kind of feel like it's parentheses because at those maxes and mins, I think you're neither increasing nor decreasing. They don't count off either way. Skip the first one. I do want to do this one. And we'll do the piecewise. Find the critical values, intervals of increasing, decreasing, and relative extrema.
X plus 2.
Okay, this packet that I'm about to hand out is due on Monday. And we have some bookwork to go along with it. One of them will be due tomorrow, or I want you to at least do those two more times. In fact, we'll take a little pause really quick. Monday, the first page 198 is what's due tomorrow. 10 problems. Oh, 5. 5 problems. Nothing. And it's critical. Relatively extreme stuff. You can start working on the packet. Just anytime it says absolute extrema, know that you can't do that yet. So on the packet, you can work like number 1, identify the intervals with increasing and decreasing and find extreme. Can you do that already?
Yes.
Absolutely. So go through and kind of see the ones you can do. Go ahead. If it says absolute or global, that's the ones that you don't probably know how to do yet. Yeah. Local relative, you know how to do. Absolute, global, you don't. Okay. So this derivative is 2/3 x plus 2b negative 1/3. Do we agree? Now normally I'm okay with you leaving it that way, but if I want to know if the derivative is 0 or undefined, it would really help me to rewrite that. Do we agree? So I'm going to rewrite this to be 2/3 cube roots of x plus 2. Is everyone okay with how I did that? When are fractions equal to 0? What makes a fraction equal 0?
The top.
When the top is 0. Is 2 ever equal to 0? No. So this is not equal 0. Is it ever undefined? When is it undefined? When the bottom 0. Is that still a critical value? Yes. So negative 2 is a critical value.
Wait.
Remember, our critical values are undefined points because the maximum could happen at a sharp point or at 0. So this derivative is undefined at negative 2, so it's still a critical value.
So that could be like the horizontal tangent. Is that why?
It could, well, no, it could be a sharp corner.
Well, so we just said the bottom equal to 0, and that's what it came out to be negative 2. How did it come out to be negative 2?
What's negative 2 plus 2?
Negative 2 plus 1/3 point. Wait, with the square root over it though, wouldn't it?
What's just negative 2 plus 2?
Negative 2 is 0.
Right, and then what's cube root of 0?
0.
And what's 0 is 0.
0. Oh.
So if you just look at that one piece, but that's what a calculus does to you. Overthink there. Okay, put negative 2 on a sign chart. Am I doing anything different with an undefined value versus a no? So far, I'm doing exactly what I would do. F prime less than negative 2. What's the number less than negative 2? Negative 3. If I plug it in, I get a negative on the bottom. And so a positive divided by a negative is negative. If I pick a number to the right of negative 2, I get a. So what is negative 2? The relative minimum. How do I find the minimum point? Plug in negative 2 into the original, and what do I get? 2. So I have a relative min at negative 2, 0. If we had more time, I'd have you graph this in your calculator. But it looks like this.